Cool! I'm gonna do another video. Today I'm gonna talk about blockchain networks. And the reason why I'm doing this is because I was trying to test something actually, and I needed more complex setup. And I was trying to figure out how to do like testing on Mainnet without using your money. And then I found a way, but it wasn't well documented, so I figured I might just talk through how the networks work. And and how I would approach it again. So this is a video that I wish I would found when I was searching for the information before. So I'm going to talk about blockchain network. What's a network, you might ask? So as you might be aware, the whole architecture in blockchain is not one server, one client, or many clients talking to server as traditional, Web 2 world. But we have many nodes, many things doing stuff, and they are all connected to each other. They all broadcast updates to each other. And then there is this consensus mechanism magic that kind of picks one of those nodes in the network to do a next block, like a next change to the state of the system. So that's why it's a network. And then we would just have like a mainnet network, which is the main, the network that everybody knows. That's the network. That's Ethereum for Ethereum. That's Avalanche for Avalanche, and so on. Then you would have a testnet as well, quite often, which is used by developers like us. So that's a similar setup. So it's again a network on the internet. It's many nodes talking to each other. It's much less nodes because there's no financial incentive normally for people to run a node on testnet. While in the mainnet, if you run a node, you get the miner reward or validator reward for whatever it might be. On testnet, you don't get that. It's just kind of built for developers to have the same. You can think of it as a staging in Web 2 world. Like it's supposed to be as close to production as possible, but not being production, so you can still test there. So on the testnet, there's a way to get the cryptocurrencies without buying them, and then actually play around and try stuff there. And then finally, we have a local network, I guess, but it's not really a network because it just runs on your laptop or your computer, so it's just one node in this system. But it still behaves in the same way the network would. It does still produce blocks. It does validate it, I think, to some extent, I guess, because you can do weird stuff there. But you have a full control over it, so you can change the algorithm if you would like to. But all the stuff for us as a Solidity developers or Web3 developers, it all works very much the same. So you can test there as well. And I'm gonna the order you can see: local, testnet, fork, mainnet, and then mainnet fork. It's pretty much how you would approach some Web3 project. You start local, then you do a testnet fork, and then you do mainnet or mainnet fork, depending on your use. Those two can be in the opposite order. Cool. I'm not gonna be just talking, so I'm gonna do those things while talking, hopefully, and maybe stuff will not blow up. Cool. So for that, I'm thinking let's create a simple smart contract we can deploy places. I'm gonna create a folder here called networks. I don't need to do that. Then I'm gonna go open a terminal here. And the thing I'm gonna do here, I just created this networks folder, which is empty. And I'm gonna call Truffle the init. I don't know if you need to specify the folder, maybe. Cool, so now we have some scaffolding done. We can also say Truffle create contract. Let's call it greeter. It's gonna be very simple. Cool. So now if we do ls, you should see, it's maybe easier to look at here. So now we have this networks thing. There's a contracts, which has this new greeter. Like you don't need to worry much about this. We don't need actually smart contract to talk about it, but it's easier. So I figured we can do that, but we're not gonna go too deep. So I'm just gonna fix the migrations here. What? Oh no, sorry, not migrations, but initial migration. That's one that I wanted. So I'm gonna add the greeter here as well. So we deploy it, hopefully one less E. I hope I didn't do 3. Greeter. And then greeter as well. So that's good. Now we can go to the thing here, actually. We don't need that. We can make a field here. Let's make it string. Ooh. String. Let's call it greeting. And let's initialize it to hi. Sounds good. And then we can have a function which is going to be setter for this. And it's going to get a string in it. So new greeting. And we're going to make it public. Boom. And all we're going to do here is just going to assign this thing. Like notice we have no like requirements. Anybody can call this. This is just really for testing. Yeah, and then we're gonna have maybe a function, say greet, that's just gonna greet us. And it's gonna be public and view, I guess, because it's not gonna change state in any way. And it's just gonna return the greetings. Like if we would make this public, we don't actually need this function, but let's have it. I think we need to specify the location as well. Cool, so we're pretty good. I guess this compiles. So if I go back to my notes, so now we're gonna start with a local development. I just quickly hacked a smart contract, which I think is pretty amazing. And now I want to prove this to myself first and then to the world. So to do that, we would start on local environment. So you can do back in terminal. I can say Truffle develop. And this did something. What it did, it started the local, blockchain on this. This is your local host, so this is your machine, and this is a port 9545. And it also gave us 10 accounts that we can play with. So if you do, there's a variable called accounts that holds these accounts. And then if you look at their balances, they're pre-filled with some money in it. Which you obviously need for many things, including there should be like 100 ETH or equivalent of that. And we need this because the next step for us is to actually deploy the smart contracts. And if you run deploy here, it's going to compile and deploy these smart contracts. So if we look here, deploy migrations smart contract, that's a Truffle thing. You can, it keeps track of which contracts are deployed and which are not, so it knows which one not to deploy. And greeter, our cool contract. So the fun thing now is that if we look again at the balance of the account 0, we see that it's less, and that's because we burned some ether in order to deploy these contracts. So it's good that we had some ether in that account, otherwise it wouldn't work. Yes, and now what we can do is we can just grab that greeter. we can say greeter deployed. So this, and we need to wait this. This will fetch instance of the deployed contract that we just done. So now greeter, if we do address, I guess, gives us some address, and this is the same address we would get here. Here, when we deployed it, right? It's 6D2 at the end, and it's 6D2 at the end. So that's the same contract. And if we say greeter, greet, it says hi. And then if we say set greetings, and we say, I don't know, networks rocks, not very original. We've just done a transaction, right? We changed the state in the blockchain because we changed what's in there. So we've got the transaction received back. But this one looks all good, status true, it worked. So now if we do greet again, we're gonna get networks rocks, which shouldn't have S now because my English is just way below that level. So this is pretty cool, right? Now you can test your thing manually in this blockchain. But you say, well, this is not good enough for me, which I fully understand. What you can also do is use Ganache UI. So let's do that. So I'm gonna open a new terminal because that's gonna kill it. And I'm gonna say Ganache UI, boom. So you can look into, it's the same suite of programs basically. It's Ganache and Truffle, and you can look into how to install them. It's kind of neat tool, and we're gonna need them further as well. But when you start it, you can basically do quick start or create a new workspace. So let's do that. I'm gonna create a new workspace. And then what you can do is you can add your project there. So you need to go to wherever you created wherever your Truffle config is, and then you select that, and it will append this project in here. We're gonna see in a second why this is useful. So you're gonna save workspace. This looks very similar, or looks very different, but again we got 10 accounts with each pre-filled 100 ether. It's just graphical now, so that's really cool. It also tells us here that it's running on your local host, which is this 127.0.0.1 is your local host, so that's your machine, and on this port. So that's kind of nice. So let's copy that port. Now when we did Truffle, we did develop, right? It created a new network and connected to it. But now we have already existing network, that one running in Ganache, and we want to connect to it. For that you use console. So this will not try to create a new network, it will just connect to some. And what you pass here is a network, and then you identify the network in some way. But for this to work, there needs to be a configuration for what the Ganache network is, how to find it. So that's why, that's where Truffle config comes into play. So I'm gonna hide this, I think. So Truffle config is this, It's this like a big file, and it's when we did Truffle in it, it kind of generated this file, and it's mostly commented stuff because it's trying to be helpful and it's trying to help you out. So one thing, there's a section networks, and here we define our network. So we can define our Ganache network here. We can say it runs on localhost, and the port was something else, right? The port was 7545. It's very small, but that's what it says here. So we're going to change this to 7545. Cool. Now let me make this bigger again. So now what we can do is just say Truffle console network Ganache, and it's going to go to this config. It's going to find this Ganache network, and it's going to figure out how to connect to it, and it's gonna hopefully do it. Cool, so that did just that. And if we do accounts here again, the cool thing is that we should just get 227 at the end. So that should be this one, right? So these are the same accounts we see here as we have in this accounts variable in our system. So let's try to do the same thing here. We first need to deploy, because we haven't done that yet in this network. Again, this is a new network, has no idea what we've done before. Now we've deployed it. Next up, we're gonna fetch this greeter instance. Boom. And we're gonna go right ahead and set greetings to be Ganache rocks. And you get successful thing, and then when we do greeter, greet, boom. It works the same way, right? So why would we bother with this Ganache thing? And the reason is because now when we have look at Ganache, we can see that we have this awesome UI that shows us the balance without us typing any commands. I need to remember what is there to type to see the balance. You can also see the past transactions that happen in this network. So we created some contracts, we created some migration contract, we created the second contract, the greeter contract, and we did some other thing which is like Truffle migration, so we saved which contract was deployed, and then we interacted with our greeter contract right here. So you can see this, so this is more similar to like Etherscan or something like that. You get access to something like that, not really. You can even watch for events and maybe see logs. That's kind of cool, I guess. But if we edit our project in, what I've done, we get also see contracts here. And if we click on greeter, we actually see the internals of it. So we see the variables that are being set there, and we see all the interactions there. So if we now would go back somewhere and set greetings to Ganache's and then somehow reload this, I guess if we click here, yeah, so we can see that the state here changed, and then we have two transactions. Yeah, so that's Ganache UI. It's kind of neat for what it does. Let's go back to the notes, figure out what I forgot to say. So that was the Ganache UI. In both cases, we got the pre-funded accounts with some native coins in it. By native coins, I mean Ethereum, if you come from Ethereum, but yeah, internally it doesn't matter how you want to call this native coin, because if you're aiming to deploy for, say, Avalanche, what we're going to do in test network, you can just call it, AVAX, whatever you want. Yes, a lot of tooling calls it Ethereum. We saw Ethereum everywhere, but on the base level of the protocol, it doesn't matter. But what I found these local environments most useful for is just unit testing. I don't do much manual testing here. Yeah, I don't do much manual testing here, because in normal life, you don't interact with the smart contracts via console as we've done. You have some sort of, how do you call it? Well, like a front-end application, like a dApp. So you want to test that. And that becomes a little bit harder if you're trying to do it against local. And especially if you're like a bigger team and you have more people doing it, then it's just easier to deploy in test network, which we're going to see in a second. But you still want to write unit tests. That's very important bit. So we can kill this. I think we don't need you anymore. One thing we can also create here is test greeter. So I'm just gonna, we would need another video to talk about how to write test. But basically, you write a unit test like you would for any other code. So you have some sort of assertions, you have some sort of setup, and then you hope thing works. And then what you can do is you can say Truffle test, and it will like create a new network, run the tests against it, and close the network. You can also specify a network here, so you can see Ganache. We want to run it against. That doesn't look correct. We can also run it against other network, not just our local one. So that works as well. So back to our nodes. So that's what you would use localhost for, local networks for the most. You would run the tests there. You write the test suite and you run it there. Cool. I'm gonna, I guess, close the Ganache now. If I can find it. By the way, now we should see like all these transactions, contract creations, you see? That's from our test running. So it's actually this network, so it's being used. Now it's dead though. Cool, so let's look at test network. As I mentioned, all these big brands or big chains, Ethereum, Avalanche, they have their own networks. If we look here, let's go to MetaMask. Yeah, if you look here, we have a Ethereum mainnet, and then there's Robston, Kavan, Ringkabi. These are all like a test network of Ethereum. But if we look at Avalanche, I decided I'm gonna do Avalanche this video, but it doesn't matter really. It's just that I'm recently building on Avalanche, so why not? And here we're gonna see RPC URL, and there's this section. I think this is it. You might be asking, what's this RPC URL? When we have this network that we said we have, and there are many of these nodes everywhere in the world, and we want to communicate with that from our laptop. Unless we're running node locally, which is overhead, it's not necessary in most cases, we need to connect to one of these nodes, one of the nodes in this network, and send them our request. It's called RPC, Remote Procedure Call, because that's the protocol you communicate with the node. So you're sending it, telling you what to do, basically. And what these RPC URLs are is those are the actual addresses of the nodes that you can talk to. And here you can see that there's Avalanche mainnet settings and there's a Fuji testnet setting. So Avalanche has one testnet which is called Fuji, and we're gonna try to set it up. So let's do that. So back in here. Back in here, we would again go to Truffle console and do something like, let's see if we can figure it out. If we copy this, I can call this avax test, and the host isn't localhost anymore. It's this RPC that we took. So this should be Fiji, right? And the port, did it say a port? No, it didn't say port. So you can take the chain ID if you want, which is network ID, and we can get rid of the port. Well, let's see if this works. Truffle console network avax test. I don't have high hopes. I didn't prepare this part. And something went wrong. Attempting to connect, check your network connection, could not connect to port undefined. Yeah, I don't know what the port is though. Sorry about that. Let's try. I don't know. What could be? the default. Default is none. Didn't it specify a port? No, it did not. Okay, let's do a quick Google. Oh, that's many. I'm actually gonna cheat and open another project right here, where I know how I configure this. I just did that. Okay, never mind. Okay, I've just done that, so let's do that. We can do this. Whoa! So instead of network, you would do provider. Network ID shouldn't matter, so you can do star here. And then you need this HD wallet provider, which is a thing you can comment here. And it's also a thing that you need to install. Well, so we need to, this is unplanned, but it's okay. We're gonna install some stuff. Boom. So this HD wallet provider is like used when you have your private keys as well. You would just package them in the HD wallet provider, as we're gonna see. Just gonna do like empty array here. Hopefully this is gonna be fine. And then you say provider or URL, and this is the same URL we had before. So let's see if this will be happy then. Okay, well, while we're waiting when it installs, we can do a next step that we could use. And we're gonna create AVAX prot. Cool, so now we have all installed, and if things work well, we can try this again. Ah, god damn it. Oh, this is better. So it's saying that it couldn't create mnemoing on private keys. Well, that's fine. We have a thing. Last time we created private keys generator. So this is just creates a new private key. So we should be able to just put the private key here. This is not use private key anything. This is just like thing we created last time on the last video. Yep, let's try. Cool, we're in. So now we have this one account here. The problem here is that if we try to do deploy, well, that's actually kind of interesting thing. So it's gonna fail, I hope. And it fails because insufficient funds. Because if we look, because we just generated this account, so if we look at the Web3, ETH, get balance. Balance of this account's 0, it's 0, which is not good. It's not enough. We can, but this is what the test network are for, right? So how do you get this ether or currency? So there's such a thing called faucets. I wonder if there's a faucet here. No. So you would go to Fuji, Avalanche, faucet, boom. And you basically say that you're not a robot. What is this stuff? Am I failing these? Okay, cool. And then you paste, now this is the private key, is it? We want this address. And we say, please give us some monies here. Oh, this is correct. And we can request 10, 10 of these. Test AVAX. Transfer successful, it says here. I don't know how long it's gonna take, but let's see. Oh yeah, cool, we got it right away. But here is another proof that we are actually talking to this testnet fork. So now we can do deploy. And this will now work. And what we can also do back here, we have here Snowtrace, which is sort of Etherscan. If you're Ethereum, it's the same thing. You can paste in the address that we're using. You can see that there are transactions. So you can see the transactions here. It's very good for testing, as I mentioned, and it worked the same way as before. So we don't need to like test the greeter anymore. Cool. So let's go back to networks. So now we tried this, faucet. We got the coins. This is how you like connect to it. Kill this. So next up, this I would use for like a manual testing. So I would have the app deployed somewhere, and then talking to this network, and you can do all the interactions, see how long it takes to do stuff and stuff like that. When I'm ready, I would go to Mainnet, right? And this is where the fun starts. So you start dealing with the real money. So you actually need Ethereum or AVAX on your wallet in order to deploy the contracts in the first place. And you need to obviously pay it to get those. So it's not a good idea to test there. That's where you go for the actual release. Yeah, so that's why I'm not going to do it in this video. But sometimes all the testing we've done so far is not good enough. Then you need mainnet fork. So why would you ever need that? It's if you need to integrate to different systems that are already live on that network that you're trying to do. Because if you're running something locally or even on testnet, that thing that you're trying to test against might not exist there. So you obviously would build some sort of mocking mechanisms. You would build some mocking smart contracts that behave similarly to what you're trying to integrate, but it's never 100%. So it's always good to like test on the real thing. But now we just said that it's expensive and maybe not a good idea to test there, because not only is it expensive, but when you deploy the smart contract, it's there, right? It's deployed. So now you will have two versions of it after you fix some bugs. So it's kind of difficult. So especially in decentralized finance, when you have all these, in Avalanche there's a YieldYak or Aave, and they are all connected. And then if you're trying to build on top of that, you want to talk to them, to the real contracts. So that's where the fork comes in. What does that mean? The forking part is that it's going to look at the mainnet at specific time, and it's going to take a snapshot of it, put it on your laptop, and starts running a local version of this network on your machine. So from that point, it starts to behave the same way as if we would have the local stuff at the beginning. So if that makes sense, let's try to connect to it. So I have some examples, like you're trying to use some other NFT which exists on that system, or I was saying some aggregator. So you want to aggregate different systems, you want to aggregate different DeFis, show them some dashboard or something. And then you would use mocks in previous stuff. So what we can do to create this fork is run this command. So this is Ganache, again, familiar name. It's the same suite of tools that we're using: Truffle, Ganache UI, and Ganache CLI. CLI means, it's terminal. I stands for interface, and this is command line interface. So it's a terminal, right? And then you can specify a fork, and then you give it where it should fork from. So this URL is the RPC of the real thing. So if we were here, Avalanche mainnet settings, so this URL is what you would use. Ethereum, you would use, you know, whatever, Infura URL that you get from there. Cool. So let's try that. So if we just copy that thing, we don't need that anymore. So let's go again here to some clear. Run this. Address already in use. Okay, so I'm running something else somewhere else. How do I get rid of this? Okay, I think I found it and killed it. Nice. So it told us that it's doing this. It also gave us 10 accounts to play with, which is very neat. We're gonna get into it in a second. It told us where it cloned from, some network ID, and timestamp where it cloned from. And it told us that it runs locally on 8545. So now we can go back to our trusted Truffle config. And I was wrong, we don't actually need this. And we can create our fork. Actually, let's just copy this and call it fork. Because as we saw, it's the same host, right? 122 localhost, but just the port is a little bit different. So it's 8545. So it's 8 here. This looks good. So now here we should be able to say truffle config connect fork. Boom. What? I didn't say. No, not config, sorry. Truffle console network fork. It's getting late here. Cool. So we can see we have these accounts. The crazy thing here is that we have access to them, but not only that, we actually, they're again pre-filled with some native token. Get balance. Becomes 0. So they again has 100 of this native token here. Although obviously on the mainnet that we forked from, these accounts didn't exist. They had 0, right? Because we just created new primary keys. But that's how this forking mechanism is implemented here. That it also, after it forked, it adds some accounts and fund them. Because otherwise it would be really difficult. You would have to have an account that already had some money before you fork in order to use it. But that way you don't need to. So that's very neat. So we can do deploy now. We could do that. And it works. And now we have all the stuff that we normally need. To prove it to you, I'm going to go to Snowtrace here, which is again Etherscan, but this is the production one. Let's look at whatever. This is like somebody last transaction that happened in the system. So this address has around this much AVAX, right? So if it's really fork, it should be very similar here. So you can say web3 ETH get balance, and we can pass the address, and we see that we got the same number, right? We can even do web3. Now I'm just being fancy. From way to convert it to human friendly number, and it fails. Okay. But yeah, we don't need to worry about that. So I would need to figure out why it's not working, but that's not important. So this is the number 42. This is where the comma comes, I think. And if you look back at that account, it had like, well, it has 44 now. So you know, it got some more AVAX. In the meantime, I was talking, probably. Must have. Cool. So this is pretty much all, I think. Let's check my notes again. Yeah, that's all I wanted to talk about. it's very powerful testing against this mainnet fork, but it's really hard to find information about how to do it. So I hope this kind of helped. Always feel free. I have a Discord now, I think. I should link it to the videos. So feel free to join there. There are like 2 other people. And hit me up with questions. I'm happy to answer. Cool. Thank you. Bye. Have a wonderful evening.